Hello, everybody. Well, I'm Jordi Baylina. Currently, I'm very focused in the ZisK project. ZisK is very much about the ZK VM and trying to accelerate ZK as much as we can. But today, I want to explain kind of a new project or a new idea or something more that's more related to privacy. And the idea is, let's imagine how Ethereum should be with privacy in mind. I mean, how we can add a layer of privacy to Ethereum. How Ethereum should work if we had privacy on that. So, well, it's kind of a dream, okay? Let's dream how it should be. And this is how I think it should be. Let me just see if this works. I don't know what I need to push. Maybe it's the other one. It's this one, right? Ah, there we go. Okay, well, first of all is all the transactions that are sent to the mempool or that are sent to chain, they should be encrypted. Nobody should see what you are doing, okay? All these transactions should be just put in blobs, in a ledger, I mean just commit to these transactions, okay? But these transactions needs to be processed, okay? And the state of Ethereum should be also private, means that nobody have access to that, so it's a state. It's encrypted. This is what's represented here is encrypted or RAM state, okay? And it should be some, let's say, some entity, we'll see then how we solve, and this is probably the difficult part, that should take the encrypted transactions, decrypt it, execute it, decrypt also the state, decrypt, execute it, and re-encrypt that state, okay? And with that, so imagine that this entity is an obfuscation box. It's something that anybody can do. This key is a key that, this encryption key is a key that nobody knows, okay? But everybody can execute that, okay? So this is the idea of obfuscation. Obfuscation will see this is not exist, this is not possible today, but I hope that someday it will work, okay? But let's focus how this would work. I mean, how, from the user perspective, how this would work, okay? So in order to do that, let's imagine, for example, a normal ERC20 smart contract. The state would be encrypted, so the state, nobody would be able to see what are the balance, but and only with the constant functions, you can see the balance. And the idea is that all the permission, all the people that can see this balance, you can program this ACL, you can program these permissions with Solidity itself. The idea is that, for example, it's in the get balance, instead of returning just the balance, you first check if the person that's asking for the balance has the right to see the balance. So you selective disclosure exactly what you want to see. And you can do that in Solidity itself. You can also, for example, you execute things, and sometimes maybe you have events, okay? So you want to notify things to somebody, okay? So you can have events, but the idea is that you can encrypt those events. Maybe those events would be also in the ledger, and these events could even have a tag so that users can recognize some event and can decrypt those events. So this is very interesting for sending things to one to the other, okay? So you see privacy in this way, you see that you don't need to modify too much Ethereum. I mean, Ethereum is fully programmable, so all the privacy can be programmed in Solidity itself. Maybe it would be some library smart contracts to handle all the privacies, I mean, the conversion of the public keys with the private keys, ACLs, so some helping, some tooling that will help to do that. But everything that I said, you don't need to modify Ethereum at all. I mean, you just program Ethereum, you just program privacy using the EVM, using Ethereum itself, okay? So you see that these advantages is fully compatible with the current Ethereum. Even it could be updated to that, and it would be backwards compatible where everything is public, but you can start writing new smart contracts that have privacy. You know, all the tooling could be embedded in the single smart contracts, it's backwards compatibility, and you see that we can create a kind of a standard for privacy to build on top of Ethereum, okay? And this is one of the advantages of this, okay? Disadvantages, well, the disadvantage is that this is not possible today, which is acute. But what's the best thing that we can do right now? I mean, what's the best effort that we can do? Well, alternatives that we have. First one, an obvious one. I mean, trust me, bro way. I mean, have a centralized server. This is the one that has the state. You decrypt this. Of course, you need to trust this central party, which is not good, but well, it's a good start. I mean, you can start something on that. Okay, but let's try to do it something a little bit better than a central server. Okay, it's okay. There is another way. It's okay. Let's try to maybe split the state, split the data in a kind of a shared secret, so that we have like different servers that has this information. Okay, and then we can have maybe a stateless processor. Okay, that can process this data. Okay, so this has, I mean, this model has, has a lot of advantages, but well, it can work. Of course, it has limitations, but also has advantages. This trustless layer, it can be, for example, a TE. And the nice thing of this is, even if the TE is broken at some point, you can, because this is stateless, you can replace this TE by something else. Okay, and you can keep the TE. Okay, so maybe that separating the data and having a TE, this should work enough. Of course, TEs, I mean, they are breaking every year, and it's bad at this point. Okay, but it's the best. Maybe it's the best. It's a tool that we have. Okay. The other next thing that we can do, which is interesting, is okay. We split the data. We have the TE, but the TE can also have generate a zero knowledge proof inside the TE. Okay, so this would give us the warranty that we are just trusting the TE for privacy, but we're not trusting the TE for the funds. I mean, you maybe, if those keys are revealed or you have some problem on the system, maybe the privacy would be leaked, but not the funds would be leaked. Okay, which is, I mean, it's bad, but it's not that bad. That's losing the funds on that. Okay, if you don't want to trust TEs, we still have some solutions. Okay, so one of those is using co-snarks. I mean, the idea of co-snarks is that it's a kind of a multi-party computation, but you use the snarks just to be sure that all the parties are acting in the right way. Okay, this is, I mean, the nice thing of this is that you don't need to trust hardware. You can do. The problem of this is that's quite, I mean, it's quite slow. Okay, and also. Okay, and the last thing, the other way that we can do is with full homomorphic encryption. The problem of the third one is that you need a lot of interaction for doing this multi-party computation, and then you end up centralizing the servers because all end up in the same place. Okay, so the other way is using FHE. The idea of the FHE is that all these data providers, they encrypt with FHE. We have a processor that with FHE is just executing the state, and then the result, we use the multi-party thing to just decrypt to decrypt the state, to decrypt the outputs of this state. Okay. But just to mention here, I mean, the end game of this is is obfuscation. Okay? Obfuscation is, I mean, it's not available right now. It's definitively possible to do it. Okay, so it's indistinguishable obfuscation. What's actually possible? Actually, I want to mention here that there is a couple of interesting projects that, I mean, they are not ready yet, but there are interesting efforts to do that. One of those is local mixing. Local mixing looks very promising, but it's not, I mean, it's not proven yet, okay? But there is a lot of work that's happening in that direction. The other is machine ID. It's from the Ethereum Foundation. There is a research team that's also working in that, and there is other research efforts in the world that are trying to solve this. But let me say that the quantity of people that's researching in obfuscation is really, really low currently, okay? So we should push that direction. I think that pushing obfuscation is important. I know that right now looks like impossible. A lot of very smart people try to solve and have not been able, but this definitively is an important piece for having full privacy. Okay? If we want to do a schema like the one that I presented, that's very simple, it would be great to have this tool. Also, obfuscation is very useful for lots of things. I recommend just seeing some of other presentations that I did about obfuscation that talking about different applications that works very well. So here, promoting research and trying to find people to look on the obfuscation is the call that I want to do from here, because I think that this technology is super important. In regarding the first options, I want just to mention here that we started recently a team that's working in that. We want to write the specification of this layer for Ethereum. We want to write a kind of a proof of concept, because I'm super interested in the usability of this privacy. And I think that start having smart contracts and start having blockchain applications where they have privacy in mind is a must. It's something that we can advance doing right now. And yeah, that's very much what I wanted to explain. Thank you for listening. And yeah, let's do Ethereum private.